Welcome back to the Git It workshop part 2. We are learning version control using Git. Let's get right to it. If you're just tuning in for this video, you probably want to go back and watch the first video in this series on Git. Otherwise, you're going to be kind of lost. In case you haven't seen that video, I'm going to put a link to it in a little pop-up bubble in one of these top corners. If that's not you, then let's go finish up this Git It workshop. Remotes. This is part of the magic of Git, so this is a good concept to have a good grasp on. If you don't have remotes, then you're not going to get the benefits of the distributed nature of Git. You're not going to have it making it easy for you to collaborate on projects with other people. When you put something on GitHub, that copy lives on one of GitHub's servers. This makes it a remote repository because it's not on your computer, but on a server remote somewhere else. By pushing your local, which is on your computer, changes to it, you keep it up to date. Others can always get the latest versions from your project by pulling your changes down from the remote and onto their computer. This is how everyone can work on a project together without needing access to your computer where your local copy is stored. That's basically what I talked about in the intro. Just now we're going to be putting it into practice. We're going to create a remote repository. You want to sync your local version, so the repository we've been working on in these last few exercises, we want to sync that with one stored on GitHub. To do this exercise, you've got a GitHub account. I'm going to pull up my browser. Actually, I think we're done with this, and this is in GitHub, so I can just sign in over here. This is not where we want to be. We want to create a new repository. And what are we going to call this repository? Let's see what Git It wants. Actually, I'm going to pull this over to this half of the screen. Go to GitHub, log in, click the plus in the top right, and click New Repository. That's what we have done. Give it a name that matches your local repository's name. Hello World. I'm pretty sure these don't strictly have to match with the local directory. You can kind of do what you need to do. If you have a way you need to remember to find it on your computer, but you need to sort of present it to the world as a different name, I think you can do that, and it's not a problem. It says give it a short description. We'll call it our first Git repo. Make it public. So we got public here. That's the default. Don't initialize with a Readme. If you were going to create a repo on GitHub, and then you were going to pull it down to your computer and start working on it there, then you might initialize this with a repo and add a Git Ignore. If you're doing what we did and you're creating locally first and then you're going to push it up to GitHub, you don't really want to do any of this because you just want an empty repo that you can fill with the files you've already got in your project. So now we're going to create the repository. They're going to tell us about what Readme, Git Ignores, and licenses are. Git does a cool thing. Let me actually go back to this repo we were looking at before. Okay. Just to demonstrate what a Readme does for your repository, this is the project's Readme. Let me go into that and show you what it looks like. It's just, oh, actually they're going to render it, but here's what it looks like. It's just this text file. It is Markdown. If any of you have used Markdown before, you probably recognize that. If you haven't, it's just a really simple text markup language that translates easily into HTML. And what GitHub does that's really nice is if you have in the root of your repository a file that's called readme.md, and there are a few other file names it works with, maybe even readme.txt, but what it will do is it will render that file at the bottom of your repository source listing. So here you've got all the files in this repository, in the Git It repository, and then if you keep scrolling down, you'll have this readme.md, which is actually the rendered out HTML from that raw markdown readme.md we were looking at before. So that's really cool. It's a way you can document your projects, and it's immediately visible to anyone who visits your repo page on GitHub. So it's nice, it's handy. Not necessary for what we're doing right now. And then a Git Ignore is just a text file that lists every file that you want Git not to pay attention to. And it's really simple. It's just one per line. You can either list the whole file, or if you list a directory, it won't try to track anything in any of those directories. Really handy. And then the license file is so that you can tell people how they are allowed to use your code. If you're putting code in a public repository on GitHub, that means anyone can go look at it. And they may, if it's a project that's useful to them, they may also want to use it. Maybe it's a library that they want to integrate into one of their projects. And the license file will tell them what rights they have to use that and include that in other projects. Can I use this at all? Can I use this in a project I'm going to sell? If I use this, do I have to give credit to the person that made it? Can I modify it, or does it have to stay the way it is? There are all sorts of different licenses. They give you a website you can go to here, choosealicense.com, where you can go through a bunch of different licenses. And let me tell you, if you want to have a fun Friday night, go to Choose a License and just read some of those licenses. The MIT license, that is some fun stuff. Let's connect to our remote. This is pretty easy to do. I'm going to get my terminal back here, and let's just clear out the buffer so we can see everything. To do this, we're going to type git remote add origin. That is the name of the remote we're going to add. Now, the next thing we need is we need the URL from GitHub. So let's flip back over to our browser, and I'm going to switch to the tab that has my repository in it. I've got this set up with SSH. If you don't have that set up, it's probably going to be here on HTTPS. Either one of these will, well, you have to set up SSH, so probably you're just going to use this unless you've already got SSH set up for GitHub. But what I can do is I can just copy this URL, and then I can paste it right here at the end of my command. This is going to add a remote to our Git repository. That remote is going to be called origin, and here is where that remote lives. Let's try that. Looks like that's done. Your local repository now knows where your remote repository named origin lives on GitHub servers. Think of it as adding a name and address on a speed dial. Now when you need to send something there, you can. Okay, here's some extra instructions for Windows users. If you have GitHub Desktop, a remote named origin is automatically created in your local repository. In that case, you just need to tell it what URL to associate. So on Windows, if you installed GitHub Desktop and you try to add this origin, it's going to probably give you some sort of error that says the remote origin already exists, something to that effect. So what you're going to do instead is you're going to run this git remote set URL origin, and then you're going to give it your URL. That will just attach that URL to the origin, to the remote that's already there called origin.
Question from Michael: how do you set up SSH? Do you gotta?
Oh yeah. GitHub has some pretty good instructions. I did it like 7 years ago, so to be honest, I don't exactly remember. I think it involves generating an SSH key and then copying the key and pasting it into the settings on your GitHub account. Now you want to push everything you've done locally to your remote repository on GitHub. This is something you'll do often so that your remote version is up to date and matching the state of your local version. It has a branching system so that you can work on different parts of a project at different times. We're going to go over that later in the workshop. The branch we're on now is master. I think I showed you that a little bit before, and you can see that if you type Git Status, it'll tell you on branch and then the name of the branch you're on. When you push and later pull from a project, you tell Git the branch name you want and the name of the remote that it lives on. In this case, we're going to send our branch named master to our remote named origin. We do that with this command, git push origin. So that's first the remote you're going to send to, and then the name of the branch you're going to send. Git push origin master. This shows one of the advantages of using SSH with Git. because if I added the remote with SSH instead of HTTPS, I would not have to provide this username or the password. So here's what I'm going to do. I'm going to flip back over, and I'm just going to change this over to SSH git set, what was that command? Git remote set URL. Origin, and I'm going to use my SSH URL. Okay, everything else will be the same. That's what you'll be doing. So I'm going to git push origin master. So I'm pushing to the origin branch. I'm pushing to the origin remote, pushing the master branch. Now go to your remote repositories page on GitHub and refresh the page. Let's do that. Let's see the fruits of our labor. All right, look at that. Here's our first Git repo. Here is our readme.txt file. And like I said before, if you have a file that's called readme.txt or readme.md, it gets rendered on the main page of your repository in GitHub. Let's verify this one. Okay. In this exercise, this challenge, we are working with forks. When you fork a repository, you're creating a copy of it on your GitHub account. Your forked copy begins its life as a remote repository. It exists just on your GitHub account, not on your computer. Forks are used for creating your own version of a project. I'm actually going to skip all this description. I'm just going to tell you what a fork is from my perspective. A lot of the reason you would have a project on GitHub is because you want to be able to collaborate with other people on it. You want other people who find your project useful to be able to come in and fix bugs, add new features that they need for their applications. You want them to be able to contribute code back to your project. And the fork is sort of the mechanism that GitHub has to facilitate that. So if I am on a repository, like this Hello World repository, that I want to add something to, let's say I realize that this is missing a feature, it needs another line in the readme.txt, I can fork this repository, and what that will do is in my GitHub account, it will create my own copy of that repository. Then I can clone that repository to my computer, which really just downloads it. So this is sort of the opposite way that we set up the repository earlier. We started on our computer. We created the repository on GitHub, and then we pushed the code from our computer up to GitHub. When you fork a project, it will start out on GitHub, and you will clone it, which copies it onto your computer. Once you have it there, you can go in and make whatever changes you think it needs, and you can push those back up to your remote repository on GitHub. Once you've done that, you can then create a pull request. What that's doing is you're asking the maintainer of the original project to integrate your code back into the main project. They will get a notification that they've got a pull request for a project, and they'll be able to look at your code and discuss it with you if there's something about it that they don't like, or if they want to know why you did something a certain way. You can have that discussion, and then once all that dust has settled, if it's ending up in a state where they want it to become part of the main project, then they can merge your pull request and your code becomes part of the original project. That is, in essence, why you would want to fork and sort of the whole process of contributing to open source. Let's run through this exercise and see what they're going to have us do. They've actually got a repository set up they want us to fork. And that is this github.com/jlord/patchwork. I'm going to copy this and paste it in because my default browser is not Chrome. But I have it with the font bumped up really nice so you can see it. Okay. Oh, that's not what I wanted to paste. Okay, let's just type this in. github.com/jlord/patchwork. Here we are. This is the project we're going to fork. Let's go over here on the top of our GitHub window, just under the navigation, just under our profile pic there. We're going to have this fork button. I'm a member of a few different organizations, so it's asking me where I want to fork it. Yours will probably just fork right away, but if I click this, it's just going to fork it into my account, which is the sort of the default behavior if you don't have any organizations that you belong to. And then you get this cool copying animation with the fork in the book. What we're looking at here is our forked copy of the Patchwork repository. You can see that it's no longer under JLord, it's under me now, and yours will be under your account. It tells me that it was forked from this. I can always go back and look at the original project if I want to do that. Now we have the fork. That part's done. The next step is to clone it locally. We could just work on it on GitHub. They've got a little code editor, but we don't really want to do that. We want to work on it on our computer. To do that, I'm going to flip over to my terminal, and I'm going to change directories. I want to get out of this project directory I created earlier because I'm not doing this inside the Hello World project. To do that, I'm going to change directories, cd space, and the directory I'm going to change to is one directory above this one. The way you denote that is with 2 dots. So cd 2 dots takes me to the parent directory. So in this case, that's going to be my projects directory. There we go. Now I am in the projects directory instead of the Hello World directory. One cool thing about cloning is that you don't need to make a directory beforehand. It will make a directory for you that is named for the repository you're cloning. So we're going to do git clone, and then we need the URL of our repository. And it's not this URL. It is, if you scroll all the way over here to the right, you can click this clone or download button, and then you can just copy this by clicking on that button. Now I will paste that in, and here we go. It's pulling down that repository. And it looks like I am cloned here. I mentioned that that creates a directory named for the repo that you're pulling down, but what it doesn't do is it does not put you in that directory, so you still need to change directories, cd, into your new directory. I'm going to clear out my buffer here. I am doing that on my Mac with Command K, if anybody else has interest in doing that. It's not necessary. I just like to have the big blank open space. Now you've got a copy of the repository on your computer, and it's automatically connected to the remote repository on your GitHub account. So if we type this command, they're giving us git remote dash, not remove, remote dash v. It's going to show us the remotes. We have a remote called origin, and here's the URL for it. That's both where we're fetching from and where we're pushing to. So both directions of the origin remote point to that same place. Connect to the original repository. What if the original repository you forked happens to change? You'll want to be able to pull in those changes too. This is useful if you're trying to contribute back to a project. You're going to have to integrate your code into their code. If you're contributing to a project and you're going to push up this pull request and say, hey, bring my code into the project, you want to make sure that your code will merge with whatever the current version of the project is. You don't want them having to clean up your pull requests. By connecting back to the original remote, you can always keep the original project current and make sure that your code is integrated into whatever the current revision of that project is. So that's what we're going to do here. We're going to add that remote, git remote add upstream. That's just what we're naming this remote. The other one is called origin. This one's called upstream. It doesn't have to be, but it's sort of a convention. We'll stick with that. We already know the URL. Will it let me copy it? No, it won't. It doesn't want me to copy and paste out of Git It for some reason. Now let's list them out again. Looks like it got added. We have origin and we have upstream. We should be good now. Let's, oh, we need to, okay, yeah, we're on a new project now. So we need to select our directory again. I'm just going to navigate up to it here. It is Patchwork. And let's verify. We are verified. We're good. Let's look at branches. A branch, you can use it for a lot of different things. One of the most common ones is to add a new feature. So if I am working on a repository, and it's especially important if a lot of other people are working on this repository with me, when I start a new thing, a new project inside that project, like I'm going to add this big feature, it's a good practice for me to create a new branch. What that will do is that will leave the master branch pristine in the state it was already in while I do my experimentation or work on my new feature over on another branch that is not interacting with the master branch. And they've got a little visualization here. This line represents the master branch, the line that goes through the middle, the just kind of straight horizontal line. Each of these lines that come off represent branches. So they've got branching, and then I think each of these dots is intended to represent a commit. Here they've got this cool feature branch. It comes off of master at this point, so it's a branch off of this commit. It starts here, somebody does some work on the cool feature, they make 4 commits, and then that gets merged back into master. All that work that used to be in the branch is now on master. The nice thing is that in the meantime, while it was a work in progress and maybe not fully functional or just not something you would want to be in the master branch, it wasn't. It was off on its own branch, isolated from everything else. That's nice because it makes it easier to work without constantly sort of bumping into each other. You have your own branch where you're doing your work, other people are working on their own branches. You'll bring them back together into master later on when they're complete. You can also use it for just experimentation. Like, I use this routing library for my application. What if I use this other one? It's got some cool features. Maybe that would solve some of the problems we've been having with this one. So I'm going to branch and just swap out those routing libraries and integrate the new one and see how it works. If it works, great. I can merge it back into master. If it doesn't, I can just abandon it, or I can delete it, or whatever. And master is never the wiser. Those are pretty useful. Also, GitHub will automatically serve and host static website files in branches named GH pages. This is a branch that GitHub in particular pays special attention to. This free service is called GitHub Pages. Since the project you forked creates a website, its main branch is named GH-pages instead of master. All repositories that have a GH pages branch with website files can be found live online using this pattern for the URL. So if your repository has a GH pages branch, then it also has a URL where whatever is in that is served up as like just a static website. So you could have a single HTML file in there, or you could have an HTML file with some images that you have embedded in the web page. If you have that branch, it's going to get this URL. It'll be your GitHub username .github.io / and then your repository name. It's a pretty cool thing. Here we're going to create a new branch. When you create a branch, Git copies everything from the current branch you're on and places it in the branch you've requested to be made. While still inside of your local Patchwork repository, type Git Status to see what branch you're currently on. We know we're on GH pages, but let's do it here just so we can see it in this format. On branch GH pages. Here we go. Create a new branch and name it add-username, where your username is your username. The way we do that is with this git branch command. So we're going to type git branch, and then it should be add-raddevin, or your username. Not all. Don't everybody make a branch called add-raddevin. Branches are case sensitive, so name your branch exactly the way your GitHub name appears. Now we have a branch with a new name that is identical to GH pages. They mean the branch is identical, as in the source files are identical, not that the name is identical, of course. To get into that branch and work on it, you check out a branch. Git checkout, and then add raddevin. Now I am on that new branch. If you don't have fancy stuff going on with your terminal and you want to verify, you can use Git Status, and you'll see on branch and then your branch name. I just want to show you a really quick trick here that sort of combines those two steps into one. So what I'm going to do is I'm going to check out master again, and I'm going to branch off of it. Oh right, not master. Git check out GH pages. Let's go back here. Oh crap. Pages. There we go. Okay, now I want to create a new branch, and I know I immediately want to switch to that branch. Here's how I can do both. Git checkout -b. I'm not sure why they chose B, probably because something else was already taken. Git checkout -b, which tells it I'm going to create this branch and check it out. We'll just say test branch. You can see that branch did not exist before. Git checkout -b created and switched me into the branch. So now if I run git status, I am on the branch, test branch, which did not exist, got created, as well as checked out, all in one command. That's just a cool tip to make things a little bit easier for you. And now we're going to switch back over to the add Readme branch. I think I'm going to finish out this challenge, and then we'll go ahead and call the stream for now. We are going to create a new file named add-username.txt, where username is your username. And then just write your GitHub username in it. That's it, and that's all. So this is going to be pretty easy. I'm going to use the echo like I did before, and what I want in the file is my username, which is Readme. And I'm going to use the right angle bracket to redirect that output from the echo command to a file. And that file is going to be add readme.txt. Oh, no, that's not exactly right. It's in the contributors folder in Patchwork. So we're going to go to contributors. Ooh. Contributors / and now add readme.txt. Okay, that'll get it into that file inside that folder they wanted it to be in. Let's try that. I just want to look at this, just take a peek at this. Okay, yeah, contributors. I'm going to list the contents of that contributors directory to make sure my file's in there. Oh, right. Yeah, this is going to be a lot of files. Let's see if we can find me. There I am. Okay, that should be good. I'm going to use cat. Just make sure that the contents of that file is what I want it to be. Looks good. Just my username. Next, we're going to check in our changes. We can look at the status. After we made those changes, we've got an untracked file, contributors / add-readme.txt. I'm going to now add that file. Contributors. Now it's staged. And the next step is to commit it. Git commit. Give it a commit message. They're saying to just do this. In the real world, that probably wouldn't be a great commit message, but we'll just go with it here. Now we are going to push it to the origin remote, which is our remote on GitHub. So that's our fork. We need to tell it the branch name. We are up. Let's see if it will verify this. Found branches, changes have been pushed, file in contributors folder, so it looks like we're good. Hey everybody, this is Devin coming to you from the future. I'm here months after the original Get Together stream aired, and I wanted to go back into this Git It workshop and just finish it up, wrap up those last few exercises. Looks like we've got 4 left. So let's get into it. The exercise we're on now is this one. It's a small world. Add a collaborator to your project. And I'm still kind of refreshing myself on exactly what we had done here, but it looks like we have forked a project, Patchwork, and we're going to be adding a new collaborator, and that is this bot. Let's see, I'm in GitHub over here. It looks a little bit funny because I'm zoomed in far enough that we're actually looking at the mobile version, but let me just... Okay, there is our repo. We want to add a collaborator that's in settings. And that is under, okay, this is actually important. GitHub has changed a few things, tweaked a few things in their UI. So where this used to be under collaborators, once you go into settings, it is now in manage access, I believe. Yeah, here we go. Invite a collaborator. Let's try repo robot. Not repo robot. Okay, here we go. Let's add that user to the project. Okay, we are awaiting their response, pending an invite. I'm curious, do they automatically accept? Yeah. This bot automatically accepts. So it's accepted our invite to collaborate with us at this point. Now let's just go back here to the workshop and click verify. And we're good. Repo robot has been added. Let's move on to the next exercise, and that is pull never out of date. Keep your file up to date by pulling in changes from collaborators. Pull from a remote. If you're working on something with someone else, you need to stay up to date with the latest changes, so you'll want to pull in any changes that may have been pushed to the central GitHub repository. Since Git is distributed, that means there is no canonical copy of the repository. Every copy of the repository is equal. The repository on your computer is just as good as the repository on your lead developer's computer or your CTO's, or if you're just working on a personal project, your friend's computer, or even the one that's on GitHub. It doesn't get any sort of elevated status. It's just another copy of the repo. That means your friend or coworker who is also working on this project can push changes up to GitHub that you might not have. And to rectify that, you pull. That will take those changes from the remote repo and bring them down into your local copy so that you're current and up to date. What has RepoBot been up to? See if RepoBot has made any changes to your branch by pulling in any changes from the remote named origin on GitHub. This is something we're going to do locally. This is not something we're doing on the GitHub website. This is something we're going to switch into our project directory locally and pull into that local repo from the remote. That means we're going to do this from our terminal on our computer. We're going to use this command to do it. Git pull remote name and branch name. I do not even remember the name of my branch. Oh, okay. This should be it. Add readme. You may not have this, probably don't, because this is a function of the way I've configured my terminal emulator. If you don't have this, you can type git branch, and that will indicate to you which branch you're currently on. You can see there in the top left-hand corner of my screen, the add readme branch has the little asterisk out to the left. That means that's the current branch. If you are watching this whole video in continuity, then you're already switched to your own branch that you just created in a previous step. I wasn't sure that I would be because, like I said, it's been months, but it looks like I am. Now I need to pull, and I'll do that with git pull. The remote name is origin, and then the branch name is add readme. Looks like we're already up to date. If nothing's changed, it will tell you already up to date. If there are changes, Git will merge those changes into your local version. Did Repo Robot make changes? Git tells you where changes were made. You can open that file and see Repo Robot's updates. Let's go ahead and hit verify. I guess that's it. We pulled, There were no changes. Okay, cool. We're up to date. Let's move on to the next one. These are pretty quick, or at least have been so far. Submit a pull request to the original Patchwork repository. Okay, and this is going to tell us a little bit about pull requests. Often when you make changes and improvements to a project you fork, you'll want to send those changes to the maintainer of the original and request they pull those changes into the original so that everyone can benefit from the updates. That is a pull request. This is sort of the primary mechanism by which people contribute to open source projects. You start by identifying the project you want to contribute to, you fork that, you pull it down to your computer, make your changes. In most cases, you'll want to and need to test those changes in some way. Some projects even require you to write automated tests, but not all do. Once you have met all the requirements for contributing and you've written your code and you're ready to send it off, that is the point at which you submit a pull request. And that is basically asking the original maintainer of the project to bring in your new changes as part of the official project. To do that, we are going to go to this URL. Hopefully that copy worked. I don't think the last one did. Let's see if this one does. Nope. All right. We'll just type this in github.com/jlord/patchwork. I'm copying instead of clicking. I could have clicked on that link. You'll probably just click on that link, but I generally don't use Chrome. I've got it zoomed in on GitHub so that you can see it really well in the video. So I just need to copy and paste, or else it'll try to open it in my default browser, make a big mess. Now, this is the original project that we forked and made additions to, and now we want to bring those back into the overall project. Often, GitHub will detect if you pushed a branch to a fork and display it at the top of the original website. If you see that with your add username branch, you can click to create a pull request from there. I'm not seeing that. It might be because, I wonder why. It might be because it's been a while. It's been a long time since I've made the change. I don't know if the timing matters in displaying that pull request button, but at any rate, it doesn't matter. We'll just follow these manual instructions. Click the green new pull request button. I'm actually not seeing that one either. What if I go to pull request? Okay, here we go. Now on the pull request tab for the repository, I have a new button. I'm going to click that. Okay, this is also not exactly what I want. This is just comparing changes on this repository to this same repository, not our fork. But I also have this link at the top. If you need to, you can also compare across forks. Let's try that. Now my head repository is going to be my fork. And okay, there we go. So now we have my fork selected and we're comparing my add raddevin branch. What are the changes? There we go. I have added me to the list of contributors. Now we create pull request. This is where we would write out our message, and if you haven't had a discussion about this pull request with the maintainer, this is where you might explain what you're trying to accomplish and why you chose to do things the way you did, maybe even why you think this would be important to incorporate in the project. In our case, I know this is all just being done by a bot somewhere, so I don't really need to worry about the documentation very much. So I'm just going to click this Create Pull Request button. Looks like Repo Robot has already merged our pull request, which I believe is the entirety of this exercise. Let's click Verify. Found your pull request. We are done. We just have one more exercise to go. Merge, ta-da. Merge your branch locally, delete the branch, and pull from Upstream. Merge locally. Oh, okay, so this is teaching us how to clean up. Once you don't need branches anymore, you can delete them locally and remotely. This is helpful so that you don't end up with a pile of old branches. I'm really bad at doing this. here's how I should be doing it. First, move onto the branch you want to merge into, in this case, the branch GH pages. We're back in our local terminal, back in our copy of the repository, and now we are checking out the GH pages branch. Tell Git which branch you want to merge. Git merge, add raddevin. Okay. There we go. We are merged. Now I can delete it locally using git branch -d and then the branch name. There we go. Now we can push that deletion, or I guess we're not actually pushing that deletion. I guess we are deleting on the remote as a separate operation. Git push origin and then -- delete, and then our branch name, which is add raddevin. This is affecting our remote. This is not affecting the original repository. What this will give us is, if we want to continue contributing to this project, then we won't have a lot of branches lying around that have already been merged in. It just makes things a little bit cleaner and a little bit easier to manage as we're continuing to work on this project. Next thing we do is we pull from the upstream. To do that, we're going to git pull upstream GH pages. The upstream remote is the original project that we forked. Okay, cool. And you can see how long it has taken us. We've got a bunch of new people have added themselves to the contributors. Wow, like a staggering number of people have added themselves to the contributors since we originally did this stream. But now we're all up to date. Our local copy is current with the upstream, meaning the original repository. We got our pull request merged, so we are officially contributors to this Patchwork project now. Let's click this last verify button. Branch merged and branch deleted, so we're good. That officially completes the Git It workshop. Thanks for joining me, and look forward to seeing you in the next video.